Hi, in today's video I am going to be explaining the question number 7. The question number 7th part A, write a k-means clustering algorithm and discuss how the initial centroids influence the result. So the best way to explain this is visually. So I have taken here an example of these data points that are plotted here in an x-axis and the y-axis. I have assigned two random initialization points. These are here and they are randomly chosen. So these are the centroids that I have randomly chosen to initialize the algorithm. Now what I am doing is drawing a line to best separate these clusters of points together. And now what I'm going to calculate is these points that are actually being separated. So this is the first group and this is the second group. So the second group and the first group, we need to calculate the center of mass basically for them. So once we calculate that, let's say that we have something like this, uh, where the center of mass can be calculated by the summation of the all the x coordinates of a specified class divided by the number of observations. And similarly for each coordinate we can do the same thing for each dimension. We only have two dimensions here, so it will be easy. We just need to calculate the center of mass. So we obtain, let's say the new center of mass is here. So our old position, our old centroid was here, and we had a line over this. And let's say the new center of mass for this cluster is right over here. Our initial centroid was right here. So we move these old centroids to the new position, and we move this for each and every cluster that we have created currently. So once we do that, there would be a point where there would be no change between the new position and the old position. That is, once we make this and this our new centroid, we can create a new decision line that would be L2. So this classifies class A and class 2, class A and class B. And once the step arrives that the next COM, the next center of mass calculated is the same, exactly the same as the current centroid, we stop the algorithm and we know that we have now created two clusters or whatever the k clusters that we have chosen. Now talking about how do we choose the optimal k. So for choosing the optimal k, what do we do is basically we calculate the WSS, the within cluster sum of each possible entry. So to calculate WSS, the WCSS is given by the summation of j from 0 to n, 0 to k actually, within the summation of I equal to 0 till n, and this is the summation of the distance of pi and cj squared. So this distance can be calculated for each and every centroid. We are calculating the distance of each and every point from each and every centroid and summing that up for each k. So once we do that, we can actually get a curve that looks similar to something like this. We can plot a curve between WCSS and the number of clusters k. So we get something like this. So we choose the this kind of resembles an elbow, like elbow shape for a curve, and we select the optimal k by selecting the lowest point here, and this would be the optimal k for our algorithm. Now we need to talk about the random centroid initialization trap. So what happens is we get the wrong amount of clusters or incorrect correlation between data. So let's see how does that happen. Let us say I have a data point, data collection like this. First I will draw this quickly. Uh, Clearly we should have three clusters. there is no doubt about that, that we should have three clusters. But initializing randomly, we might initialize the centroids, let's say here, here, and here maybe. So after the clustering algorithm works its way, we get the center of masses of each of these groups and assign those center of mass calculated to these centroids. We can end up something like this. Like, this is the wrong classification. We clearly know that there should be two clusters here and there should be one single cluster here. So to avoid that, we basically need to select the correct position for each and every centroid. So to do that, we can do something like this. For each and every data point, since we chose the correct amount of k using the WCSS method, we'll initialize something like this. And thus we will end up with clusters like this, and this. This is the expected output of the algorithm, and this avoids the ambiguity. However, there is an algorithm called K means plus plus, which basically initializes these centroids based on a heuristic of squares of distances. So at first we choose the centroids at random, but for each of the remaining data points, we compute the distance d to the nearest selected centroid, and then we square that distance, and we select the farthest from that. So, for example, I can demonstrate this visually. Instead of algorithmically writing this, visually it makes it a little bit more clear. Let's say we have a data point like this. Let's say this was our randomly initialized uh, basically the centroid. This was the first randomly initialized centroid. What it's going to do is basically calculate the distances from each and every point. So like it calculates the distances from each and every point, and then we shall square the distances. So let's say this one, this distances are squared. So I'm representing this by a thickened line. We can clearly see that this distance is the greatest, right? So the greatest distance is selected, and we place a new centroid right here. So this is centroid 2. This was centroid 1 and this is centroid 2. And similarly, we initialize the k centroids for each and every iteration. We calculate all the distances. So this is a little bit computationally more intensive, but this leads to better results in k-means clustering. So that would be it. We shall solve the second part on our presentation. Thank you.